Hello everyone, I am Rahul G. We are continuing our replacement preparation series 2023 in operating systems topic. So in the last class we started our chapter number 3, which is called as processes, and we have talked a lot about processes, like what are the states of the process, what actually a process is all about, what are the states of the process, and we also talked about what are the system calls needed to for process concepts like fork, execute, for execute, for about, exit, everything like in the operations, like creation of the process as well as the termination of the process. So, and we have also seen about the queuing diagram, which is help us to represent the states of the process as well as the operations of the process. We have talked a lot about in terms of process, am I right? Yes. So one of the important topic in terms of process is called as interprocess communication. Interprocess communication. So let's give you an example. The example is nothing but, let's take a system. I'm gonna have a system. Let's take a system. The system consists of more than one process. Let's take it as P1, P2, and P3, P4, etc. We can able to say in such a way that P1 and P2, P3, P4 can have two different types of things. That two different types, nothing but P1, P2, P3, and P4 are independent to each other. They can be independent to each other in such a way that P1 does not depends upon P2, P2 does not depends upon P3, P3 does not depends upon P4, P4 does not depends upon P1, and all the vice versa is not possible. So they are independent to each other. This can be our case number 1. Our case number 2 is the process can be cooperating. Cooperating is nothing but both the process make sure that one process gets affected by another process. That is, the execution of P1 depends upon P2 or P3 or P4, or the execution of P2 depends upon P1, P3, and P4, and so on. So it might be like this. So the process within the system can be independent to each other, or they can be cooperating in such a way that one of the process gets affected by other process too. So what is the reason? What is the main reason for cooperating the processes? So what is the main reason for cooperating the processes? First thing is all about the process, both P1, P2, P3, P4, the information what the process is going to be is should be shared among the processes. That's going to be the major point. So that's going to be the major point what we're going to talk about it, the sharing of informations. Secondly, the speed up. Why? Because if P1, P2, P3, P4 gets communicated with each other, if one of the process P1 does not able to do the work at a particular point of time, it can able to make sure that it can give the work to P2, P3, or P4, so that I can able to see there will be a higher throughput, and the speed up, the speed for the speed of the computation will be drastically increased. And you also have modularity and convenience. So the cooperating processes, the processes are not independent to each other. We are not going to talk a lot about this. We are going to talk about only the cooperating processes. The cooperating processes need need one thing called as IPC, where IPC stands for inter-process communication. Within a system, there might be lot of processes. How the process get communicated with each other. So there are two models of IPC, guys. Okay, let me wrap this. There are two models of IPC. One is all about shared memory. We'll see a diagram regarding how shared memory as well as message passing will be there. So there are two models of IPC. One is all about message passing. One is all about message passing, and other one is all about shared memory. Other one is all about shared memory. Let's have a look about how message passing and shared memory will work in terms of inter-process communication. So this is how the diagram, the communication models of inter-process communication will have. So inter-process communication will have. Let's take process number A and process A and process B. Process A and process B in such a way that they are supposed to get communicated with each other. They get communicated in each other in such a way that there should be a pathway in between process A and process B. So there is a case that there should be a message passing gateway between process A and process B, right? So that's going to be my message queue, which contains M0 to Mn of messages. What is all about shared memory then? Shared memory is going to be, in terms of a memory, I'm going to have an extra space called as shared memory, where the shared memory is going to be accessed by both process A as well as the process B, right? So with the help of the shared memory, I can able to say both process A and process B gets communicated with each other. Right, guys? Clear? So there are two communication models. One is all about message passing and another one is all about shared memory. Let's talk about the cooperating process. So far, I have said about independent process do not get affected by each other. Why? Because it does not depends upon execution of other process, but the cooperating process gets affected by the execution of other process. And we also talked about the advantages of inter-process communication, advantages of process cooperation. And one of the important thing in terms of interprocess communication is nothing but another example, another important problem where lots of papers or lots of questionnaires has been raised for this problem. The problem name is all about producer consumer problem. Very, very important, guys. Why? Because even though I'm not saying in terms of placement preparation series, in terms of your curriculum too, if you see that all each and every question paper will have the producer consumer problem as base. Why? Because these kind of problems provide the overall paradigm of process overview, as well as some of the integration as well as the communication between the process. Okay, so the paradigm of computer cooperating process, we know there will be two important integrities. One is producer, another one is consumer. So what is all about producer and what is all about consumer? Let's talk about that. So producer is the one who's gonna produce the information. The producer is the one who's gonna produce the information, and the consumer is the one where it is gonna accept or consume the information. Clear? So there should be a communication in such a way that both producer as well as consumer should be integrated in such a way that when the producer produces the information, the consumer should consume the information. There can be two types of buffer what you have in such a way that, so while you are sharing the information, there can be two types of buffer. One is unbounded buffer, another one is bounded buffer. What is unbounded and bounded? They represents the size of the buffer. Unbounded is nothing but unlimited. Unbounded is nothing but the unlimited slice. So you can have limitless space where you can able to store lot and lot of information. But bounded is nothing but based on the size k we are supposed to store the information. Clear? Okay, let's talk. Let's give you an example how the bounded buffer, a shared memory solution, will be there. We have created a structure. You guys know in terms of C, structure is nothing but a data type, or we can also call them as a data structure, which can store, which can store variables of, different data types. Okay, which can store variables of different data types. So this can help us to store different data types. So what I can able to store, so if I'm going to have information containing different data types, then I can able to create a structure which contains different types of data type. But so now this type of structure is going to mention the information about the process. Am I right or wrong? Yes, this gonna give me the information about the process. So I'm gonna give the buffer size. Only up to the buffer size I can able to have the information. So this is nothing but a bounded buffer. So here the size is 10, so I can't able to store any information above the size 10. Clear? Okay, now, so how the producer is going to produce the information and how the consumer is going to consume the information, right? Bounded buffer in such a way that I'm going to get only my, what I say, how bounded buffer in such a way that I can able to get only the I can able to produce only information up to the size called as buffer size. Okay, I've created a while loop. If in percentage buffer our size is equal to out, then the major thing is it has been done. So that means produces an item in the next produce. So what I'm going to do is nothing but buffer of in is going to be next produce. I'm going to increment my n. So I'm just providing, and what is the next produce is nothing but I'm going to update the next produce. Then those next produce is going to be stored inside my buffer, only up to the size of buffer size. This is how the next produce is the next produce is the information what we have. The next produces the information what we have, and only up to buffer size I can able to store the information. And buffer, that means this buffer of n is nothing but my buffer storage. Okay, clear up to this? And why I'm doing this is the thing that it should be in terms of circular. Okay, clear. This is all about producer. Now the producer has produced the information, now the consumer to consume the information. So what and all we have in terms of buffer of out, I'm going to consume it, and I'm gonna take each and everything one by one. So this is going to be my consumed until my buffer size is being reached, until my buffer size has been reached. Clear? This is all about the producer as well as consumer problem in terms of bounded buffer in the inter-process communication, where the both the producer as well as consumer gets communicated with each other with the help of the information which is being shared among them. Okay, let's talk about shared memory. So far, we have talked about bounded buffer, and we also talked about a kind of very important problem in inter-process communication. As we said in the beginning, there are two different scenarios where inter-process communication will happen. One is all about shared memory, another one is all about message passing. In terms of shared memory, as I said, there will be a separate space where, there will be a separate space where I can gonna mention it as shared memory. Both process A and process B use the memory, use the shared memory to get communicated with each other. And this communication will under the control of users process, not the operating system. The very, very important thing, guys, the communication is under the controls of the user processes, not the operating system. Operating system will not control the communication. What that happens is nothing but the major issue what happens while I'm creating a shared memory when both process A and process B gets use of the shared memory to get communicated with each other is nothing but the synchronization. We all know about that. At what time process A should access the shared at what time at what time process A should take care, at what time the process A should access the shared memory, and what time process B should access the shared memory. Why? Because there should not be any conflict arise when both the process A and process B access the shared memory at particular point of time t. Okay, so we are supposed to know about the concept called a synchronization. We're going to talk a lot about process synchronization in the next chapters. Okay, maybe a chapter 5, or in my series is going to be chapter 6 or chapter 7. Why? Because I'm going to separate the topics into chunks where I can able to explain you in a correct way. So we're going to have a synchronization. Those synchronize with the help of the synchronization what I have. So with the help of the synchronization what operating system is going to provide, with the help of algorithms, we can able to make sure that we can able to avoid the issues which happens inside the shared memory inter-process communication. Okay, clear. Now what is all about message passing? So message passing is nothing but there should be a mechanism in between both process A and process B. Am I right or wrong? There should be a mechanism. Why? Because unless until if we don't have a mechanism, we can't able to say that uh, we can't able to say that both process A and process B gets communicated with each other. So there should be a message system in such a way that it process communicates with each other without restoring to the shared variable. If I'm going to have a variable called as var, which is being shared among both A and B, I'm not supposed to restore the var in such a way that it is common to both process A and process B. Why? Because if process A changes the value of the var, then it will get reflected here too. Clear, guys? It will get reflected here too. Why? Because this is very important, since both var gets shared among both process A and process B. Once process A changes the value of the variable var, then it will get reflected back in process B too. Okay, and the inter-process communication facility provides two operations. One is all about send the message and receive the message, where if process A sends some message through message passing mechanism, then it is supposed to use send message operation. and the process B should you should use the receive message operation in order to receive the message. Let's continue. Let's say if process P and Q wish to communicate, what they are supposed to, let's view an example. If P and Q are two processes in such a way that they are supposed to communicate with each other. First and foremost thing, what we are supposed to do is nothing but we are supposed to establish a communication link. We are supposed to establish a communication link. After establishing a communication link, process B can exchange the message via send, and process Q can able to receive the message and further back send the message, so it can be vice versa. So they can get communicated with each other with the help of both send as well as receive messages. So I've done those so far, right? Through message passing, I've created a communication link. Then I started to exchange informations between the both process with the help of send and receive message. What are all the implementation issues I'm gonna get? What are the things I'm gonna get? Let's talk about that. So we are supposed to know how the links are established. The very important thing, how the links are established, how the communication link has been established between the process P as well as process Q. And can a link be associated with more than two processes? Why? Because in this example, we have said only process P and process Q. If there is any assistance in such a way that more than two processes can be associated within that link, and how many links can there be between every pair of communicating processes, and what is the capacity of the link? How much information the communication link can able to withstand, right? And is the size of the message that the link can accommodate may be fixed or variable. We are supposed to give in advance, or it can be dynamic, or is a link is unidirectional or bidirectional. That means only P can send, P cannot able to receive, one and Q only can receive, cannot able to send. Is there, it can be a unidirectional, or it can both send as well as receive. It is bidirectional. So there are kind of implementing issues we are supposed to think before before establishing a communication link between the processes. Okay, what are the implementation of the communication link? The first thing, I'm gonna make sure that there will be both physical as well as logical. Why? Because I can able to provide a physical wire between both. What is it? As you guys know, if I'm gonna have a computer A, if I'm gonna have a computer A and computer B, both computer A and computer B can be connected with each other through a physical link. Yes, I can able to create an optical fiber between them. I can able to share the informations. Or if computer A gets to know about the IP address of computer B, then computer A can, what may I say, share the information to the computer B. And if computer B comes to know about the IP address of computer A, then it can further give the response back to the computer A, right? So this can be in terms of network overview. Then what can be in terms of physical? How can a communication link can be established between both process A and process B? First thing is all about shared memory. I can able to use a shared memory concept or hardware bus or network. And what can be logical? It can be a direct communication or it can be indirect communication. Okay, it can be a direct. It can be a direct communication or it can be an indirect communication, or it can be synchronous or it can be asynchronous, or it can be automatic or explicit buffering. Sorry guys, my handwriting is not so good. Okay, so it can be direct or indirect, it can be synchronous or asynchronous, or it can also be automatic or explicit buffering. Let's give you an overview about what are all those logical communication is all about. Direct communication. Direct communication is nothing but process must name each other explicitly. Why? Because I can able to say that in this thing, what I'm going to do, send to P the message. So send to P the message. That means I'm explicitly saying that the message has to be sent to the process P, and receive Q comma message. In this, that the message has been received from the process Q. So I am explicitly mentioning what type of communication is happening, and based on, as also mentioning from where, from what process I'm sending, and to which process I'm sending, and from which process I'm receiving the message. right? And what are the properties of the communication link? The links are established automatically, and link is associated with exactly one pair of communication process. That means A and B. Between each pair, there exists exactly one link, and the link may be a unidirectional, but it is usually bidirectional one. Clear so far? Okay. Now, what is going to be indirect communication? Indirect communication in such a way that messages are directed and received from mailboxes. Each mailbox has unique ID. Processors communicate only if they share a mailbox. The main thing is nothing but indirect communication is they are directed. Messages are directed, but we are supposed to say they are received from the mailbox, also referred to as ports. The main thing is nothing but I can able to refer only to the port address, not to the process which has been explicitly mentioned. Let's give you an example. If I'm gonna send a message from A to B and vice versa, then I can able to say A is gonna send a message to B and B is gonna receive the message from A. So this is gonna be a direct communication. Am I right or wrong? What going to be indirect communication? I'm gonna say this message is going to be directed, but I'm not going to say from which process is going to come or which process is going to be received, but instead I'm going to receive the mailboxes. That means I'm going to have the port address here. Okay, this port address is going to be called when I'm doing this is going to be called as indirect communication. And this every mailbox has a unique ID, and process can communicate only if they share a mailbox. If they don't share a mailbox, then we can't able to say that the process can get communicated with each other, right? So what are the difference? What are the properties of the communication link from the direct communication? Links established only if the process share a common mailbox. Yes, if they share only a common mailbox, then only the links get associated, the links get established. And in terms of indirect communication, the links may be associated with many processes. I'll give you an example. Let me say that I'm a sender. Okay, my port address, I'm gonna have a port address called as AXB. If I'm gonna not sure, I'm gonna send. There is one capability in such a way that I can able to share my mailbox, and I can provide. I can what can I say? I can send a mail to more than 30 users at a time. Okay, when I know their thing, so that I can able to say my mailboxes get shared within the process. Shared within the process. So the link may be associated with many processes, and each pair of processes may share several communication links, and link may be unidirectional as well as the bidirectional. Why? Because once I send, I can get some receive messages from the users. Clear about direct communication and indirect communication, right? So there is some. I'm not gonna give you much overview about this, guys. So why? Because when you are supposed to do an operations in terms of indirect communication, you are supposed to create a new mailbox first. That you are supposed to create a new port first. After creating a port, you are supposed to receive messages through the mailbox. After sending and receiving the messages, destroy the mailbox. I'll give you an overview. So I'm gonna create a port first. After creating the port, with the help of the port, I'm gonna both send as well as receive the messages. Once after sending and receive the message has been done, I'm gonna delete the port. Okay, and the primitives can be defined in such a way that send a comma message. You are saying so you have said first you don't have anything in extra, right? So you don't have anything much define those things. So how far we can able to mention this? And we have also said that we are not supposed to provide you the process name. Then what A is all about? Here A specifically mentions all about the mailbox. I'm going to send a message to the mailbox A, and I'm going to receive the message from the mailbox A, right? Yeah, I'm not going to mention any process here, but I'm going to mention only the mailbox, which has some a kind of port number. Clear? Okay. Now mailbox sharing. They can also share the mailbox. Am I right? So P1, P2, P3 share mailbox A. P1 sends, P2 and P3 receives. Who gets the message then? Whether P2 gets the message first. Okay, I'll try to diagrammatically. I'm gonna have a mailbox called as A. There are three processes: P1, P2, and P3. P1 sends and P1 sends and P2, P3 gets received. Now I'm gonna say who gets the message first. Who gets the message first? Whether P2 gets the message and P3. So okay, let's say I'm not gonna show you that if both are linked to this. P1 is going to send the message, and both P2 and P3 is going to receive the message. Who gets the message? The solution is all about only when a link is being associated with at most two processes, both the P2 and P3 gets received. Am I right or wrong? If the link is not been associated, we can't able to say that whether P2 gets the message or P3 gets the message. They are have the capability to receive only if they been link is only if the link is being associated with them, and allow only one process at a time to execute a receive operation. The very important case, guys. I can able to allow only one process at a time to execute the receive operation, and allow the system to select arbitrarily the receiver. Sender is notified who the receiver was. If I'm going to select P2 as a receiver at a particular point of time called as T, then P1 gets to know that yes, P2 is the receiver. And after time T is equal to T1, P3 is going to be the receiver. P3 is going to be the receiver. Then the P1 gets to know that yes, now P3 is going to be the receiver, is going to receive the messages. Clear all about it? Okay. So we talked a lot about what direct communication is all about and what indirect communication is all about, and the indirect communication are kind of these things. Okay. So some of the examples of your IPC system, guys. So one is your POSIX shared memory. You can just take a snap of it. Why? Because here you're going to use a set of size object, and you're going to make sure that how the shared memory process will happen over here. And this is the POSIX procedure and consumer problem. Problem what we have discussed in the first thing. Okay. And this is for Macintosh, where Macintosh is gonna have what can I say? Gonna have a message passing system, and we're gonna have indirect communication in such a way that it is gonna have two mailbox at the creation. One is kernel, another one is notify. Kernel is gonna send the message. Notify is gonna notify whether the message has been transferred successfully or not. And examples also in terms of Windows, we have LPC, which is local procedure call. So we're going to talk a lot about local procedure call in Windows with the help of this diagram. Let's say I'm going to have a client and I'm going to have a server over here. Client server communication in terms of Windows, which we're going to term it as LPC. That means local procedure calls. The first thing, with the help of the connection port, what I'm going to have, I'm going to request the connection, and the connection port is going to handle and going to send to the server. Okay, send to the server. Then the client communication port and server communication port, both the communication port will communicate it with each other in such a way that whether the client can handle the server and whether the server can handle the client or not. So that's why I'm going to send some handling messages to both client as well as server. Once they are done, yes, server is free, we can able to get the connection request from client, and client has the capability to reach the server. Then we can able to say the section shared object, which is less than or equal to 256 bytes, I can able to say we can able to share. Clear? This is all about your local procedure calls in Windows. Okay, let's talk. Let's see about the last part of this section, which is communication in client server system. So while you are programming, you are supposed to know how we can able to establish a communication between both process called as process A and process B. So far so good. We know that process A is going to send and process B is going to receive, and there can be a vice versa too. And with the help of the operations called as send and receive, send A comma message and receive B receive A comma message. Why? Because send, I'm going to send the message to A, and I'm going to receive the message from A with the help of the operations we are going to mention it. But how? So in this way, what I'm going to do is nothing but I'm going to make sure to use the concept called as sockets. The socket is the one which has the IP address. We are going to store the IP address of both the process in such a way that the socket level communication is going to happen inside. We're going to talk a bit lot about that. And remote procedure calls. We have talked about local procedure calls in Windows. We're going to talk about RPC, which is remote procedure calls here. Then pipes, which is there, and remote method invocation in terms of Java. We're going to give you an example program in terms of Java. Let's have a look. A socket. So as I said, let's take both A as well as B. A and B are endpoints. Am I right? One is going to be a source, one is going to be a destination, or it can be vice versa too. This is going to be the endpoints. So how I'm going to make sure that how B is going to get identified and how A is going to get identified. Okay, only with the help of sockets. I'm going to have a socket called as 161.25.19.8. 1625 refers to the port 1625 on the host, right? On the host IP address, and the port address is 1625, I'm gonna have the at the socket at that particular socket, I'm gonna have this thing. And I'm gonna also have the P also has different sockets. So the communication will exist only between the sockets. I'm gonna have a socket over here. Let me draw it in a different way so that you can able to understand. One sec. Let us say called a process A. I'm gonna have a socket over here. Let us get a process B. I'm gonna have a socket over here. So they get integrated with each other. Okay. Then there will be a special IP address called as 127.0.0.1, which is called as loopback IP address, which refers to the system where the process is running. With the help of this IP address, I can able to track how the process gets run. Clear? That's a special IP address. Clear about what socket is all about? It defines the endpoint for your communication with the help of the port address what you have. Now, this is what I've said. And there are three types of sockets in Java. Three types of sockets. One is connection oriented, connection less, and multicast socket class. Data can be sent to multiple recipients. One is connection oriented is nothing but which is TCP socket, and you can also have UDP socket in terms of connection left sockets, and multi-class socket class with data can be sent to multiple recipient. This is the code where we can able to create a server socket with the help of the port number what we have. So this we'll cover in terms of computer network series, guys, because we're going to talk about TCP and UDP a lot if we are going to do that in our placement preparation series, which might help us too. And what is all about remote procedure calls? I'm going to get back here directly. What is going to be called as remote procedure calls? We talked about local procedure calls, right? What is all about then remote procedure calls? What is the difference between LPC and RPC? Let's take a user calls kernels to send RPC message to procedure X. Am I right? Okay. Now, kernel sends message to the matchmaker to find the port number. Okay, so it's gonna be a normal client as well as server communication. But how far it is gonna happen? First, we are supposed to call the kernel to send the RPC message, and the kernel will find the matchmaker. And after finding the matchmaker will receive the message and look up the answer and replies to the after receiving the message replies to the client. Then after replies to the client, then the kernel places the port pin user's RPC messenger. Then after say kernel sends to the RPC. Then after say RPC, it will send to the daemon. The daemon will receive the message and will reply to the kernel. There are a lot of process happening in terms of RPC, right? It's not a short thing, but LPC, when we compare terms of LPC, RPC is going to be the word remote depends upon it. Okay, now let's come back here. What is all about remote procedure calls? Remote procedure calls abstract procedure calls between processes on network system. Again, uses ports for your service differentiation. You can have stubs and marshals over there. I'm not going to talk a lot about this. Why? Because this remote procedure calls are higher advanced in terms of operating system. Just get to know that how both client as well as server gets communicated with each other in terms of remote procedure call by making the use of matchmaker and daemon in terms of in the server, right? Okay. And in Windows, code compiled from specification written in MIDL, which is Microsoft Interface Definition Language. And okay, I'm gonna much talk about it. Okay, let's talk about the last topic, the pipe. So far, we talked about socket, we talked about RPC. What is all about pipe? So far, so go. We talked about only that the gateway which is used to which is going to allow two process get communicated. Then what the gateway? What is the name of the gateway? The name of the gateway is going to be called as the name of the gateway is going to be called as pipe. So what are the issues? We already talked about these issues in each and every topic what we have covered so far. Whether the communication is going to be unidirectional or bidirectional. In this way, two communication is going to be half duplex or full duplex. You guys know about what half duplex or full duplex means. If not so, we'll cover that half duplex or full duplex when we are talking about the synchronization. Must there exist a relationship, if it is any parent-child relationship or not. So we talked a lot about this. We have talked a lot about this. Then what is going to be the thing? And what are the different types of pipe we are going to have? There are two different types of pipe we are going to have. One is ordinary pipe. Another one is named pipe. What is ordinary pipe? Ordinary pipe is nothing but it cannot be accessed from outside the process that is created. Why? Because it doesn't have any name in it. Why? Because only with the help of the name we can able to you can able to access. So since the ordinary pipe does not have a name in it, we can't able to access outside the process that is being created. That means only the parent-child relationship process can able to make use of the pipe called as ordinary pipe. But in terms of named pipe, it can be accessed without the parent-child relationship. So this is why I'm saying the process is writes at one end. At the right end, I can able to write the process. At the read end, I can able to read and the so this is, we can also have the producer consumer style. The producer will write the process at the right end part, and the consumer will get the information at the read end part, so that it can be more mutually. Okay, and Windows call these as anonymous pipe. Why? Because I don't have any kind of ordinary pipes over here. And what is all about named pipes? As I said, it's a more powerful than ordinary pipe. The communication can be bidirectional, and there is no parent-child relationship is necessary between the communicating processes. Okay, so far so good. Okay, so this is all about the inter-process communication and all the things which is needed for your client server architecture. So this is the end of your chapter number 3, guys, which is nothing but the process. We talked a lot about it, stating from what is all about the processes, and we talked about the states of the process. We talked about process, we talked about states of the process, and we talked about the operations of the process. We talked about the system calls. And here right now, and so far we have also learned a lot about in the first section of this video, first section of that video. And I'll also ping that in the top. You can use that to make sure what we have learned in the first section of the process. And today we learned about what IPC is all about. And in terms of IPC, we talked about message passing, shared memory. We talked about producer consumer problem, and producer consumer problem we talked about bounded buffer and unbounded buffer. And we talked a lot about the examples of your inter-process communication. And we also talked about direct communication, direct communication, indirect communication, asynchronous and synchronous communication. And we also talked about the examples of your inter-process communication in major programming language, major operating systems. We talked about Macintosh, we talked about Windows, LPC, local procedure calls in Windows. Then client server architecture, we talked about sockets. We talked about sockets, and we talked about the different types of sockets which is available in Java, and we are available, and how can we implement it through the server socket class in Java. And we also talked about remote procedure call a little bit, why? Because I'm not going to make sure that it doesn't need just know about how the same LPC happens. And now we talked about the pipe. In terms of pipe, we talked about both ordinary pipe as well as the named pipe. Ordinary pipe, we can able to only be accessed within the parent-child relationship. Can be accessed without any parent-child relationship in terms of named pipe. Clear so far? Okay, that's the end of the series. That's the end of the chapter, guys. So from the next video, we'll be covering the next chapter, which is called as threads. Why? Because so far so good, we talked only about the whole sum of process, but inside the process there will be lot of threads which is happening. Why? Because one process contains lot of threads, where because each and every thread will execute one kind of operations. So we are supposed to know about those things in such a way that how a particular process and particular threads how the threads as well as how the process gets accumulated with the help of threads, and we can able to get to know about, yes, this is the overview of this is going to be the in a full explanation about process and threads. Okay, so thank you for listening, and please subscribe for the channel. Why? Because we'll be posting the videos frequently for our placement preparation series of 2023, where we'll be covering operating systems, database management system, and your system designs. And I have started the TCS NQT 20 days challenge, where we'll be covering 75 problems in the case. So I'll be posting the link in the description box below, and also sharing the list of all the placement preparation series of operating system what we have gone so far in the description box, as well as the first section of process in the app. Please use the video for your further reference. Okay, thank you for listening. We'll catch you in the next section.
Yeah.